My name's Tim Gross. That's my Twitter handle, which is Tim in Hex, and that seemed like a good idea at the time. They didn't stop to think if they should. An alternate title of this could have been Machine Learning and the Internet of Unpatched Things. Or perhaps, because eternal vigilance is the price of liberty, we have to talk about ethics again. Oh, I can hear it now. Is this guy going to talk about the trolley problem? Oh, no. I mean, I just want to code. And who is this guy anyway? He's not an ethicist with a PhD. Why do we as engineers need to talk about this stuff? Why is it especially important to talk about ethics when we start talking about machine learning and IoT specifically? What makes them special? What makes them different from other kinds of software? And the reason that we all need to be talking about this, as Sharon Kennedy Vickers told us yesterday, what we do has impact. Let's look at some examples. Back in March, a self-driving car operated by Uber struck and killed a pedestrian. Now, the NTSB investigation is still ongoing on this, but what's clear is that this vehicle had no business being out on the road. The collision detection system was getting false positives, and so it was causing erratic braking, and so the engineers turned the braking system off. But apparently that message never got through to the field teams that were responsible for turning the vehicle's own emergency braking off. This was a Volvo, I believe it was, nor to the attendee of the vehicle. So the vehicle saw a pedestrian and ran her over. A couple years ago, Microsoft demonstrated their machine learning capabilities with the Tay chatbot. And they let it loose on Twitter to learn from whatever racist trolls wanted to teach it. Now, the experiment was stopped, and this was very embarrassing for Microsoft. Now, clearly, horrible internet racists were primarily to blame here. But the engineers, the researchers involved, failed to anticipate the vulnerabilities inherent in this kind of system. In an IoT example, last year, countless devices in the UK hospital system were taken over by WannaCry ransomware. Patient lives were being put at risk not just because of poor patch hygiene, but because of architectural flaws that allowed access to the devices, and because of flawed incentives in the US government program that developed the malware in the first place. Tesla's autopilot has been, at this point, implicated in the deaths of several drivers. We, and apparently all of Tesla's stockholders, have been constantly reassured that this is the result of improper handling and human error, and not rushing these systems into production before they are ready. You didn't think I was going to leave the home team out, did you? Thank you for your sponsorship. Machine learning algorithms may know more about us and our loved ones than we do ourselves. Target was able to determine from customer purchases, not just when a customer was pregnant, but at what stage of her pregnancy she was in. Apparently, if you buy, women will tend to buy unscented products late in their pregnancy. Who knew? Machine learning is encoding our biases, not just for dehumanizing people online, but we saw yesterday how it can reinforce structures of power and privilege, access to mortgages, sentencing guidelines. We've invited these systems into our homes, and that's kind of funny. But there's almost no oversight into what they're doing. We have unaccountable, closed-source microphones in our homes and are doing who knows what with that information. What all these stories have in common is that, like any other technical failure, there's almost certainly no root cause. These failures are the result of a complex interaction of socio-technical systems and the incentives they set up. It's unlikely that anyone at any of these organizations set out with bad intentions. But as Laneige Sims told us yesterday, your intentions ain't shit. At the end of the day, it's the people in our industry, the people in this room, who are the ones who execute and implement these systems. And the problem isn't just that these systems have real-world consequences. Software always has had real-world consequences. That's why we build it. We can go back to the 80s and look at the Thurrock 25 accidents, where software flaws in radiation machines resulted in 3 deaths. The problem is that the consequences of these systems are now being multiplied by their scale. Quantity has its own quality. A huge part of the value proposition of IoT and machine learning is the scale of the data involved. We're collecting a massive amount of data from edge computing devices, and we're processing massive amounts of data in our machine learning models. But the scope of machine learning and IoT is incomprehensible to ordinary users. If you can determine through a machine learning model that someone is pregnant, and not only that, but they're in their 3rd trimester, that isn't a piece of data that anybody willingly shared with you. In fact, most users would be incapable of understanding that you were able to derive that data. This makes creating informed and meaningful consent basically impossible. What makes machine learning especially problematic is its inherent complexity isn't being respected, only its results. Easy machine learning in 100 lines of Python. Many users of machine learning are treating these things as a black box where numbers go in and results come out. The problem with these systems having such complex inputs is that we don't understand the open-ended results that we can get out of them. So perhaps today, someone is using a William Gibson ugly T-shirt to avoid being detected by ubiquitous use of face recognition in law enforcement. But could I give you an innocuous object that makes the system see you as a wanted terrorist to swat unsuspecting targets out in the real world? What happens when a banana looks not like a toaster, like in this sticker, but a bomb or a weapon? When an accident of that kind occurs, do the engineers involved have responsibility for failing to protect against this kind of side channel attack? The flaws of self-driving vehicles and the organizations operating them are scary enough without adding adversarial environments in the mix. This is some fairly unremarkable graffiti, but it was used to confuse a machine vision algorithm 100% of the time in the field. These attacks are unreasonably effective. The embedded industry, for its part, is stuck in an archaic threat model. They're still shipping devices with shared private keys and with hard-coded passwords, right on the device. We used to say things like, well, if you have physical possession of a computer, it's game over, right? That's actually not the case anymore. We have an answer to that. It's called Secure Boot, where you use the Trusted Platform module on the chip to sign the bootloader and the operating system updates. Your iPhone works this way. But this is treated in most embedded systems as an expensive add-on rather than the default behavior. I want to talk about that in a little while. Existing solutions for IoT over-the-air updates, OTA, are mostly research projects at best. This is a tool called Hawkbit, which, depending on how you look at it, is either an insecure, comically insecure toy or an overcomplicated kit of parts. Or we're requiring trust delegation to third parties, like AWS IoT, which, that screws up your guarantees of provenance and puts Secure Boot at risk. And the problem with our complacency on this as an industry is that it invites someone to do something about it. Like these geniuses. And when they decide to act, the legal remedy is likely to be ham-fisted. We have to do something. This is something. We must do this, right? We've seen this before. And we've seen this in the evergreen fights over encryption, right? Where the government thinks that somehow they can make math available only to good people. And this is particularly a problem here in the US, where virtually all our lawmakers at the national level are either incompetent, or they and their minions are entirely co-opted by interests that are hostile to the greater public. I can't fix that problem. Today, much of our work is protected by, well, we don't actually warranty this for any particular use. This is the Apache license, but most open source licenses look like this, as do most end-user license agreements. But these agreements aren't magic talismans that protect us from responsibility, right? This is part of the legal system. We've been allowed to get away with this, and that could change. Does anybody in this room want to carry malpractice insurance for software? But even in the face of very reasonable privacy law like GDPR, we've seen our industry act with a lack of professionalism. We had 2 years of notice on this, and this kind of like, oh, I'm going to take my ball home is the best that we can do. Top post on the Orange site from another GDPR shutdown. What many posters here miss is that a big group of tech people have no interest in dealing with legal matters. Aw, poor baby. You don't actually get to be part of a world-changing industry and pretend that there are no real-world consequences. This is childish. On the other hand, if this is what organizations are doing, then maybe this is working as intended. If you can't do your job to protect the users and have to close up shop, the EU is effectively saying, mission accomplished. It doesn't have to be that way. In this interview with Mark Benioff, CEO of Salesforce, he points out that this could actually be good for our industry. It could set up guardrails. And this is deeply important because we as an industry have failed to set those guardrails for ourselves. And the larger society, our users, are starting to notice. So it's not too late. What can we do? All right, so let's talk about some of the things we could do. Let's talk about consent. Now, consent is really the only working model we have for talking about relationships between individuals, right? I consent to be part of your research. You consent to be in a conversation with me. If you're in a relationship with someone, you withdraw consent. Your partner is supposed to respect that. At this point, you know, we're still trying to drive that through with a couple of thick skulls, but like this seems to be a working model. But consent has some limits once we start getting a lot more people involved, right? Although individual consent is really the basis of liberal democracy, there are some times when we decide that the will of the community overrides the consent of individuals, right? We expect people to pay their taxes. We expect people to get vaccinated. And the boundaries of individual versus community consent vary quite a bit by culture. The GDPR demonstrates that the EU believes that individual consent is protected very strongly and should be. Whereas in the US, we kind of have this mixed bag where it's like, well, businesses are individuals, but sometimes they're given the backing of the community to override individual consent, and maybe not all the responsibility of that. We also talked about how unexpectedly derived data makes consent nearly impossible to understand. When you combine that with dark UX patterns like this, we make this work worse by manipulating consent, right? Well, you know, you agreed to this, but did you really understand it? We also see flaws of the consent model at play when we look at the Uber accident. The woman who was struck and killed didn't consent to be part of Uber's experimental driving program. She was just on the road. She wasn't behind the wheel, certainly. What does consent mean when other human lives are being treated as an externality? Just as an aside, this is the most ridiculous example from Google. Such as the pollination of surrounding crops by bees kept for honey. What coal industry PR team managed to infiltrate this into the Google results? All right, the dynamic of community versus individual consent points to a problem defining foundational values. There was a great talk by Brian Cantrell at Monctober, I think it was last year, where he distinguished between principles and values. If we can disagree on things like the balance of individual versus community consent, well, how do we define shared values? Turns out, we're not the first people to have this problem. So how do other professions solve it? Sonia Gupta, who was on stage last night, as she mentioned, was a lawyer, is a lawyer, had this great Twitter thread, which I'm going to briefly quote here. Lawyers and doctors enter their professions knowing from the outset just how heavy their burdens are. They hold human rights and life in their hands. Highly impactful professions know that their limits must be more stringent. Or, as all the comic book nerds in the room know, with great power comes great responsibility. This is the basis of professional ethics. Now, historically, licensing in professional organizations, so we're talking, you know, the American Medical Association, the American Institute of Architects, American Society of Mechanical Engineers, bar associations, have arisen from the professions themselves, rather than being imposed by the government clumsily from the outside. The professions have actually asked for the protection of government regulation. And the government delegates the licensing requirements to those organizations. And we have certifications in our industry, but I think a lot of us would agree that most of them are useless. There's a lot of rent-seeking around that, like, you know, it's these for-profit organizations that are like, well, you know, you can get our cert, and I'm going to avoid naming them. So professional organization without the consequences of regulation is basically toothless. So before we get the government involved, because that's kind of a one-way trip, we should think about what some of the side effects of a regulation-supported monopoly might be. There's a study in the National Bureau of Economic Research that showed that professional organizations mostly have acted to counter information asymmetry rather than producing monopoly pricing power. So I'm not a doctor. I go to a doctor. That person has been vetted by the boards to meet certain minimum standards of fair dealing, of competence, and of safety. And I can rely on that as a consumer of their services. So in other words, these organizations serve as gatekeepers. Well, that's maybe a little problematic, right? We have enough barriers to entry in our profession as it is. We still have a lot of work to do on that, in fact. So adding new barriers like, well, you must have this degree, or you must have this many years of experience working under another licensed developer, maybe not the direction we want to go. But the advantage of a professional organization is that at least would give us a shared baseline. Right now, we're all trying to figure this out ourselves. And we should hold each other to task. So, okay, what do we do? Waiting for regulation seems kind of like a bad idea. Relying on consent hasn't really worked out. Professional organizations are fraught with gatekeeping risks. Waiting for the industry to fix it isn't working. But we individually are the industry. We can take individual action. So we can talk, what can we do? We can talk about this stuff. There's a conference going on today, Co-Ed Ethics in London, which is sponsored by the great folks at Container Solutions. This was driven largely by Ann Curie and their CEO, Jamie Dobson. We can influence the community. There are activist organizations that are springing up over the last few years to push for broader change across many organizations. This is the Tech Workers Coalition. We can also influence our organizations. We see Microsoft employees pushing for change in what customers they want to serve. We've seen successful protests by Googlers motivated by their conscience. And we've seen Amazon employees pushing for change. Now, here's where we kind of get into the what about, right? So because we have this restricted set of common values, it isn't terribly constructive to say, well, you know, the Microsofties are protesting ICE, and maybe I agree with that, and maybe I don't, but you know, let's assume that we do for the moment. But then turn around and say, well, what about their military contracts? Or what about that time 17 years ago when their CEO said Linux was a cancer? Like, you know, these meanie head things about open source, right? But that's not helpful, actually. And while you may think that someone isn't doing enough, at least they're doing something. They're not sitting around ranting about it on Twitter. Okay, an exercise I always love. Raise your hands if you are working for an organization that's hiring. Okay, look around. Wait, keep them up. Look around. This is power. The labor market for our profession gives us enormous power right now. We can push hard for better hiring policies. We can push hard for better diversity and inclusion efforts. We can push hard for our organizations to be better. That being said, we should also cut each other some slack. You don't know much about the circumstances of any other particular person in this room. So while we should be, you know, do they have health problems? Do they have family to take care of? You know, what's kind of like their set of circumstances they bring as a human being? So while we should be holding each other to task and encouraging each other to do better, individuals do need to make their own decisions about where they work. And that doesn't make them the enemy, capital letters, unless maybe if they work at Palantir, just saying. All right. What is available to everyone in this room, regardless of our work conditions, and perhaps more effective than anything else that we can do, is direct action at the engineering level. What choices are we making as technologists? So the pipelines that we use to ingest data in many organizations are immutable event stores. This means that once data is written, it's never really erased. This is a diagram about Kafka, I think. And if you're keeping the entire commit history in there, you're going to run into a lot of problems with privacy, right? GDPR hates this. You know, you're like, well, I'm rolling it off over time. It's like, did you remember your backups? Because you still have data there. But with changes at the application level, we can actually still make this work. We could use per-user encryption keys for a stream, right? So we still have encryption at rest, which is great. But we've also made our immutable event infrastructure compatible with the right to be forgotten, right? You delete that per-user key, and the stream is no longer readable. We need to take responsibility for quality proportional to the risks involved with the software that we're building. Now, certainly this is obvious with directly life-impacting software like self-driving vehicles. But it extends to every piece of software with real-world impact. We need to be part of the chain of safety around these systems. We need to take responsibility for having a deep understanding of how the security of our systems are bootstrapped. And we need to make decisions about that that are aligned with our values. I want to talk about secure boot again. In the case of IoT, this is one of our options. So basically what happens is you provide the factory where your device is being assembled with your public key. And that gets written to a write-only memory. They blow physical fuses on there so it can never be changed. And that means that only your signed bootloader and operating system can be loaded onto the device. It's actually pretty cool. To do that, you need to make sure that your organization has PKI infrastructure in place to sign that bootloader and operating system. It needs to be part of your CI pipeline. Getting familiar with secret stores like HashiCorp Vault can really help you out with this. But there's a trade-off here. If you have secure boot, that means that your users will find it much more difficult, if not impossible, to modify and repair their firmware. So this is a business decision, but it's also a decision about values, right? And I can't make this one for you. Maybe the answer is different if it's a consumer device versus a business device. but not making the decision, not making it the decision, and not as an engineer being part of that decision-making process is abdicating your responsibility. When we deploy IoT devices, we need to make sure we're taking advantage of modern communication. You wouldn't transmit the login form to your web application over plain text, right? Right? Yeah. IoT devices typically have limited compute power, and so folks have often avoided encryption. But we can solve this with modern choices. So TLS 1.3 reduces round trip time, reduces the number of round trips you have to make. Elliptic curve keys can reduce the amount of memory that it takes to do TLS versus RSA keys. Likewise, although you can cram historical or legacy IoT protocols like MQTT into a TLS connection, modern protocols like COAP include mutually authenticated TLS to begin with, so that's part of the protocol. Much easier to do, and less resources. TLS isn't end-user facing in IoT devices, right? There's no green padlock on your IoT device typically telling you that, well, I have the thing. But secure communication isn't about optics. It's about actually being secure. What about our engineering decisions in machine learning? So let's look at one machine learning process called neural net. There's a variant of this called convolutional neural net, which is basically the same thing except a lot more convoluted. If you're not familiar with machine learning, each of these nodes in this diagram is basically just a function. This is actually like, there's a lot of smoke and mirrors on this, right? It's just a function. It takes a vector, so you take an array of data, and you run a filter function over it. And typically the filter takes each filter takes a subset of the array. And then they kind of all feed into each other with weights. And then you iterate on the weights of these inputs, and that allows you to extract features from the training inputs that from that result in interesting classifications, or in other words, decisions. This is the classic iris data set, which I learned recently is about flowers and not about eyes. So each layer builds on the layers after it, but these classifications, the decisions that come out of this, are just kind of weights in a mathematical space. And then when we're done with it, when we're done with our training, they just take the whole weights and we serialize that. We call it a model, and we serialize it, right? So it's like pickle dump. Right? And that we ship that to production. That's basically the result of this thing. And that's what we put our real world data through. Well, so in other words, machine learning models are state, which is kind of funny because we as an industry have spent a lot of the last few years trying to really manage state and get it so everything's stateless, right? Deploy your applications as stateless containers on Kubernetes. Yeah. But machine learning is effectively the ultimate stateful application. You're using software to generate software models, and that's what you ship. Which is going to really get the functional programming crowd in a twist if they ever figure it out. Your entire application is a side effect. So how can we influence those side effects? We're not very good at it. What's really interesting, and the text is kind of small here, this is a paper from Google, right? Yeah. So we desperately need in our industry better tooling to design out unexpected behavior in machine learning. We have undeclared consumers and dependencies, hidden strange loops of feedback, and these represent a source of technical debt. And it's the worst kind of technical debt because it's what John Allspaw and the snafu catchers call shadow debt. It's technical debt that you don't even know that you have. We need to remember that with any machine learning project, that human judgment is required to connect the algorithms to their impact on the real world, our business, our industry, and our community as a whole. The first rule of machine learning should always be, why are we choosing machine learning in the first place? Why are we choosing a method that has these very complex, chaotic feedback mechanisms instead of something that's simple and deterministic? Imagine explaining to your CTO, yeah, we chose this web framework and it's really great. When we get unexpected inputs, it just has totally undefined outputs on hostile input, right? She would be like, well, do you need a vacation? Are you having is this just resume-driven development that's causing us to do this? All right. When we do choose machine learning, we should choose our approach with interpretability in mind. Linear or logarithmic regression models are much easier to debug and avoid unexpected feedback loops than models that are self-optimizing. We need to remove unused features, quantify any unexpected behavior. Anything that you see that is unexpected in that model is a potential source of a side channel attack, is a potential source of these adversarial attacks, adversarial inputs. and represent technical debt. We also need to choose machine learning training inputs that reflect the population. This is a fortunate case where we can really easily align engineering ethics with the business in a way that the business understands. Because you say to your project manager, if we pick machine vision training data that reflects real demographics, then our CEO won't have to be on MSNBC explaining to them why our software is racist. Win-win. We can't rely on project managers or business analysts to take the lead on designing our systems ethically, because they may simply not understand this stuff. They may not understand the side effects that can be derived from these systems. You're the technical professional. They're expecting you to take the lead on this, which is great, because the best thing about best practices is that there are so many of them. You don't need to ask permission from your business analysts or project managers on opinions that are purely technical. You can take the lead here. I think formal Agile methodologies are actually contributing to this problem. You are not an assembly line worker punching out JIRA tickets. You are a technical professional. You are an engineer. Start acting like it. I want to leave you with this quote from Ann Curie, who's doing that co-ed ethics. We're not a craft anymore. We might feel like artisans with laptops, but what we produce could potentially be in front of a significant chunk of humanity by lunchtime. We're not handcrafting dovetail joints here. What we do have impact. Let's get to work. Thanks, folks.